statement of graphs of different laws which we have studied. How many laws we have studied? We have studied Boyle's law, Charles' law, then Gay-Lussac's law, then we have studied Avogadro's law. All this we have studied. No? So I will explain 2 or 3 graphs, then remaining I hope you can do them. Okay? Everything will be followed on the same process. Now see, you need not by heart any of these graphs. Logic and equation is what you are supposed to remember. Understood? Now see. So, what is Boyle's law? Pressure is inversely proportional to volume, no? Same equation I can write from here also. No? Actually, this equation is derived from here only. No? So, pressure is inversely proportional to volume in which condition? When number of moles of a gas when they are constant. Clear, no? And temperature also should be constant. Mass of the gas also should be constant. If number of moles are constant, mass is always a constant. Clear, no? Then in this condition, pressure is inversely proportional to volume. So if I take this volume to this side, then if I write the proportionality symbol, then that proportionality symbol is K, no? And K is nothing but nRT. Okay, ma? So this proportionality symbol is nothing but nRT. This is how I can write, no? Understood, no, ma? Okay. Now, if I want to draw a graph between pressure and volume, can you say how the graph will be? If I want to draw the graph between pressure and volume, ela untundi graph? Inversely proportional, no? Pressure is inversely proportional to volume. It means that graph should be somewhat like this. This should be the shape of the graph. Because, for example, if you take any 2 conditions, take these 2 conditions. Okay, ma? So, P1, V1. Take one more condition. Okay. So, this is P2 and this is V2. Clear, no? When pressure is very large, volume is very small. Pressure is very small, volume is very large. So they are inversely proportional to each other. If one value increases, other value automatically decreases. So that is the relation between pressure and volume. Clear, no? Now, if I draw pressure volume graph for the same system in different temperatures. For example, this is one graph, this is one graph, this is one graph, this is pressure and this is volume. So let temperature is T1, temperature is T2 and temperature is T3. Then out of them, which temperature is maximum and which temperature is minimum? Okay, ma, I have taken same system. System means what? Any cylinder containing gas is called a system. Okay, ma? I have taken same type of system and I have drawn PV graph for 3 different temperatures. First of all, I have taken at normal temperature, then I have heated the gas slightly, then I have drawn second graph, then I have still heated the gas, then I have drawn the third graph. Are you able to understand? So out of them, which temperature is maximum and which temperature is minimum? T3 is maximum, you are saying. It means you are saying that T3 is greater than, T2 is greater than T1. This is what you are saying, no? Huh? How can you say?
Volume constant.
Oh, okay. If I take at constant volume, what will happen? Pressure is directly proportional to temperature. How can you say pressure is directly proportional to temperature? So, if you look at this equation, are you able to understand, ma? So, here nRT is a constant, no, ma? nRT is a constant. So, if temperature increases, this K value also should increase, no? K is equal to nRT, no, ma? By observing this equation. So, if temperature should increase, K value also should increase. If K value increases, then the product of P into V also should increase. No, where is that product? I did not write a product of P into V also should increase. P into V is a constant. This is called Boyle's law, no? Clear? If temperature increases, K value increases. If K value increases, product of P into V also should increase. So if you take at any volume, for example, you are taking this constant volume. This is only one volume, no? Then if I raise the temperature, pressure should increase, no? Then only the product of total P into V will increase. Are you able to understand, ma? Volume I am keeping constant. It means I am checking at same volume. And I have 3 graphs. So, pressure is increasing. If pressure increases, product of P into V also increases. If product of P into V increases, K increases. If K increases, T also increases. అర్థమవుతుందా ఏం జరుగుతుందో ఇక్కడ? ఫేసులు చూస్తుంటే ఏందో డిఫరెంట్గా ఉన్నాయి. Is it clear, ma, what is happening? So PV is a constant, no, ma? And K value is how much? nRT. Okay. So therefore, at the same volume, I am checking for different pressures. Then I see that in different graphs, pressure is continuously increasing. If pressure increases, what happens to the product of P into V? Increases. It means K is increasing. If K is increasing, it means T is also increasing. So definitely, this is the highest temperature next followed by T2, next followed by T1. This is how we have to analyze the graphs. Are you able to understand? Okay. Similarly, if I draw one more graph, try to say the answer of this one. Clear, ma? So, which graph shall I take? I will take PV graph versus volume, and I will take PV graph versus pressure. Now, can you say what will be the shape of these graphs? Product of PV versus volume. Product of PV versus pressure. Parallel to x-axis. How can you say? PV is a constant, no? Ikkada em raskunnam manam? PV is a constant. So, if volume increases, pressure will decrease. But whatever it may be, product of PV will not change, no? Ade kada chadivindi manam. So, therefore, graph will be a straight line. So, whatever may be the increase in volume, product of pressure into volume is not going to change, because product of pressure into volume is a constant. Are you able to understand? Now, what about this graph? This graph is also parallel to x-axis. Clear, Nama? Because product of pressure into volume is never going to change. It is always a constant. Okay. One more graph. Clear, Nama? For example, if I take pressure on x-axis, 1 by V on y-axis. Now, can you say what will be the shape of the graph? Straight line. Straight line to what? Origin straight line into every parallel. Parallel to x-axis or y-axis? Or in the middle? In the middle you have to draw. Okay. So, this is the graph. Okay, ma? How can you say this is the graph? ఒరే మోటార్ వేసి ఆఫ్ చేసి మర్చిపోయారు మీరు అంతే ఇంకా వాటర్ నిండిపోయినాయంట ఆల్రెడీ అక్క 4కు నువ్వు వేసింది నీ తలకాయ సరే చూడండి మా సో నౌ కెన్ యూ సే వై దిస్ గ్రాఫ్ ఈస్ ఎ స్ట్రైట్ లైన్ మా see this equation here, pressure is inversely proportional to volume but directly proportional to 1 by V, no? Okay, ma? So, if you write relation like this, same relation, how can you say? Pressure inversely proportional to volume, but pressure directly proportional to 1 by V. Directly proportional to 1 by V. Clear, no, ma? So, therefore, pressure and 1 by V, they are directly proportional. So, this is the graph. Are you able to understand? I will draw one more graph. Clear, ma? See here. So, this is pressure, this is 1 by V. Clear, no, ma? I am drawing 3 graphs at 3 different temperatures. This is T1, this is T2, and this is T3. Now, can you say what is the relation between T1, T2, and T3? T3 is? Okay. So, T3 is greater than T2 is greater than T1. How can you say? How can you say? Ta cheppadam kada reason kuda cheppali cheppandi. So, if you take any one to be constant, for example, if I take 1 by V to be constant, then this is the pressure at T1, this is the pressure at T2, this is the pressure at T3. Clear, no? So, therefore, now you go to the relation. So, P is equals to nRT by V. Clear, no? 1 by V I am making constant. So, if temperature increases, what happens to pressure? Pressure also should increase. They are directly proportional, no? If 1 by V is taken a constant. Clear, no? So, if temperature should increase, definitely pressure also should increase if 1 by V is a constant. Clear? 1 by V is a constant, temperature is rising, so therefore pressure is also rising. It means definitely I can say T3 is greater than T2 is greater than T1. Are you able to understand, ma? Just if you remember this equation, ideal gas equation, any type of graph you can draw. No need of by hearting any of these graphs. Understood, no, ma? So, depending upon the situation, you have to select any type of graph. That's it. Okay? So, same graphs I will compare with the graph of a straight line. Where we have drawn? Here we have drawn, no? Pressure and 1 by V, they are directly proportional. Pressure and 1 by V, they are directly proportional. So, therefore, if I write the relation, P is equals to nRT divided by V, same equation I can write like this, Nama. P is equals to 1 by V multiplied by nRT. I can write like this, no? So, same equation if you compare with y is equal to mx plus c, then what do you understand? If I compare with the equation of a straight line, what is the equation of a straight line? Y is equal to mx plus c only, no? If I compare with the equation of a straight line, sima. So, on y axis we are taking pressure, satisfied? On y-axis we are taking pressure. On x-axis I am taking 1 by v. Okay. So therefore what is the slope of this graph? Slope of this graph is nRT. This is the slope of the graph. This is y. This is x. This is m. Understood, no? Y is equal to m into x. X-axis by this kuntunam. On x-axis we are taking 1 by v. Therefore which is the slope? nRT will become the slope. Are you able to understand, ma? So therefore in P versus 1 by v graph, if you take theta and if you take tan theta is nothing but slope of the graph. And the slope is how much? Slope is nothing but nRT. Okay. So by looking at this graph also I can say, no, if temperature increases, slope also increases. Okay. So therefore here slope is continuously increasing. No, first graph slope is less, second graph slope is greater, third graph slope is bigger. Slope is increasing means temperature is also increasing. So like this you can compare with the equation of a straight line. Clear? That's it. So see the second law, which is called as Charles law. Clear? So what is Charles law? We know, no, volume is directly proportional to temperature, and which one is a constant? Number of moles is a constant, pressure is a constant, mass of the gas is also a constant. These are the constants. When these values are constants, then if temperature increases, volume of the gas also increases. Clear, Nama? So from ideal gas equation, let us try to understand this one. PV is equal to nRT, so V is equal to nRT divided by P. So nR by P multiplied by T. So V is equal to K into T. What is K here? If I remove this proportionality symbol, I have to write a constant number. So this is K here. So if you compare this one, what is K value? K is a constant which is equals to nR divided by P. Understood, no? So in the previous condition, what was the constant? nRT was a constant in Boyle's law. In Charles law, what is the constant? nR by P is a constant. Understood, no? Now you take the equation V is equals to K into T, okay, ma, and comparing with Y is equal to mx plus C. Are you able to understand, ma? So therefore, how can I draw the graph? Let us see. So this is volume and this is temperature. Okay, ma? So on y-axis we are taking volume. On x-axis we are taking temperature. So therefore, what is K here? K is nothing but slope, m. Okay, ma? And what is the value of slope? So value of slope is nR divided by P. Clear, Nama? And what is C? Y coordinate is 0. There is no Y coordinate. Y coordinate is not there means what? Graph is passing from the origin. That is the meaning of this one. No? If there is no Y coordinate, it means graph is passing from the origin. Okay. So this is the graph which I have. So volume and temperature, they are directly proportional to each other. Okay. Now if I draw the same graph for 3 different pressures. So this is volume, this is temperature, first graph, second graph, third graph. P1, P2, P3. Now what is the relation between P1, P2 and P3? Relation between P1, P2 and P3 is how much? P1 is greater than P2 is greater than P3. How can you say? Yes. Sima, for example, if you take at a particular temperature, okay, there are 3 different volumes, no? Are you able to understand? At a particular temperature, volumes are different. Now you go for the graph. See here. So V nR by P multiplied by T at same temperature. Okay, ma? If pressure increases, volume should decrease, no? See how V and P, they are related directly or inversely? Inversely proportional. It means if pressure increases, volume should decrease. If pressure decreases, volume should increase. Volume is increasing, no? It means pressure is decreasing. Okay, ma? Therefore, which one is having highest pressure? P1 is having highest pressure. Okay. So therefore, how can I draw the graph? P1 is greater than P2 is greater than P3. This is how I can draw the graph. Are you able to understand, ma? That's all very simple. Okay. So these are the laws related to Charles law. Okay. Similarly, some more graphs. How can I draw? Let us take V by T graph. Okay, ma? So V by T versus V, and another graph is V by T versus T. Can you see? Straight line. Why? Because V is equal to K into T, no, ma? So therefore, what is V by T? V by T is a constant. Clear, no? V by T is a constant. So whatever may be the volume, whatever may be the temperature, ratio of V by T always remains constant. So therefore, graph will be a straight line parallel to x-axis. Understood now? So this is how you have to analyze the graphs. And if you draw this graph, now you take theta here. So tan theta is nothing but what? Slope. Already we have written, no? Tan theta is called slope. And slope is how much, ma? NR divided by P. So this is the slope of this graph. Clear, no? So like this, can't you draw graphs for, what is the third law? Gay-Lussac law also you can draw, no? Try to draw. I need not explain, no, ma? I hope you can draw them. So write the equation of Gay-Lussac law and draw what are the different, what you call graphs which are possible. Okay, come on. Draw chayandi. Okay, ma? Now these are the equations of Gay-Lussac law, ma? So previously we have drawn graphs for Charles law, no? Volume is directly proportional to temperature. Here pressure is directly proportional to temperature. So in the same condition, just wherever you see V, there you write P. Wherever you find P, there you write to V. That's all. So you will get the total equation. Clear, Nama? So again see here. So pressure is directly proportional to temperature, Nama. So P is equal to K into T. Okay. So P by T should be a constant. So therefore pressure and temperature, they are directly proportional, no? Now we are drawing for three different volumes. V1, V2 and V3. Okay. So definitely I can say V1 is greater than V2 is greater than V3 because at same temperature, if I take same temperature, pressures are increasing, no? So pressure can increase in which condition? Pressure can increase only when volume reduces. So therefore here volume should be maximum, next lesser volume, next further lesser volume. And this already we have studied, no? P by T is a constant, no? P by T is a constant, so variation of P by T with respect to P is a straight line. It means P by T doesn't change. See, similarly, P by T with respect to temperature also does not change. That is the graph which is called as graphs for Gay-Lussac law. Okay? Okay, Sima. So these are four graphs which are given. Out of these four graphs, we have to identify how many of the graphs they represent Boyle's law and how many of them disagree with Boyle's law. Clear? What is Boyle's law? Basically, pressure is inversely proportional to volume. This is Boyle's law, number. Or I can write the product of P into V is a constant. Okay, and what is that constant? PV is equal to nRT. This is called as constant K. Okay. Now let us see how many of graphs they are following. So pressure is inversely proportional to volume. This is satisfied, no? Pressure is inversely proportional to volume. It cannot be a straight line. So this graph cannot be followed. Clear, number? And pressure into volume, it is a constant. Whatever may be the change in pressure, whatever may be the change in volume. So this graph is also satisfied. Okay. So first graph, fourth graph, they are satisfied. Third one is not satisfied. Now let us go for this second graph. So here values are given in terms of logarithms, Nama. So we will also apply logarithms here. So PV is equals to, so if I look at this graph, so PV is equal to nRT, it is a constant. Okay. So if I apply logarithms, so log P plus log V is equal to log K. Okay. Same relation I can write it as log P is equals to minus log V plus log K. Now we have to compare this one with y is equal to mx plus c. Okay. So therefore log P we are taking on y-axis. Clear, Nama? Log V we are taking on x-axis. So therefore m is equal to minus 1. So slope of this graph is minus 1. Okay. And what is the y-intercept? Y-intercept is equals to log K. Okay. So this should be the possible graph. It means this graph of log P and log V, it should be a straight line. Okay. But here a straight line is not given. So therefore this graph is not correct. So therefore first graph and fourth graph they are correct. Second one and third one they are wrong. Okay.